Good people, sanibonani. Umakewalo. We are still doing the revision of the paper November 2019 for grade 11. So this is a function where it's a parabola function. Okay, let's get into it now. This function is telling us that in the diagram below, we have this function where we have f at x into negative x squared plus 2x plus 15, and we have a g at x where is equals to negative 3x plus k, and they are telling us that the graph cuts the x-axis into this point of negative 3 map 0 and b into 5, and the y-axis cut it at c, and it has a turning point at the end. The G cuts at the x-axis at B, Y cuts it at C, and E is a point of G such as that DE is parallel to the y-axis. Okay, now going to 6.1, they are saying we must show that the K value is equals to 15. Now this is my function, which is a g at x is equals to negative 3x plus k, and then which point I can use here, that is in this line here. I know that here they are sharing the same point of f and g, so I can substitute this point here where my y is 0 and then is equals to a negative 3, and then my x is 5 and then plus k. Now this one here gives me 15, so if I can take this 15 to the other side, since it's negative, so it's going to be positive 15, and then it's equals to k. So I can see now k is equals to 15. Now 6.2, now they're asking us to determine the equation of d. Now how do you determine the equation of d, which is a turning point, if we're having this? Again, very important. We know that x is equals to negative b all over 2a. This is how we find the x of a turning point. And then from here, it's negative into my b is 2 in this case, and then all over 2 into my a is negative 1. So my x here is going to be a positive 1. And then after getting the x of a turning point, take this x, we substitute it back into this equation, which is going to be f into 1 is equals to negative into 1 squared plus 2 into 1 and then plus 15, and then an answer here is going to be 16. Now the coordinate of d now is going to be 1 maps to 16. Now that's the coordinate that they want. We have to write it as a coordinate after finding your x of a turning point and finding the y of a turning point. Put it as a coordinate because there is a mark of you writing it as a coordinate. Very, very important. Now 6.3, they are saying determine the values of x for which the f function is increasing. Again, so where does our function increase? Now from here we are going top. I can see that my function is increasing until it reached this point. Again, the moment it reached this point at D, it's no longer increasing. It came to a stop here. As much as it would increase until it comes to a stop, and then from here going down, I can see that my function is what is decreasing. So what is the value that is there into this x? The x here is what is 1. So now I need to compare my value of x from here going to this side, because the values of x will keep on increasing this side, keep on going down. So I'm having these values of x that are from this side, and the value of x that coming to a stop here, which is what? Which is 1. Now from here going side, I can see that the value of 1 is bigger than the values of x that are going this side. So x is going to be bigger than the values of x that are going this side. So these values of x are what? Are smaller than the value of x here. Now again, I'm not going to put equals to. Why I'm not going to put equals to? Because the x comes to a stop here. So this one is not included, because the moment it reached this one, it's no longer increasing. It just came to a stop. So if you can say it equals to, meaning we are telling that it's also increasing at 1, which is not increasing. Or you can put it this way: x is an element of, now here we can say from negative infinity to, because came to a stop at 1 and then 1. Now you don't put the round bracket, because if you put this bracket here, it's wrong. Why? Because you're including this 1. So if you're not going to include that 1, you need to put the round bracket as this one, which is this, meaning the 1 is not included. So either you write it like this or you write it like this. Both of them, they're the same. Both of them, they're going to give you exactly one answer. It's up to you which one do you understand between the two. Now, calculating the average gradient between the point A and D. Now, my point D, I know that is 1 into 16, and the point of A, it's negative 3 into 1. So if I can say this is my x1, y1, and then x2, y2. Now calculating an average gradient. So average gradient of AD is equals to, now to calculate the gradient, we know is y2 minus y1 all over x2 minus x1. So my y2 in this case is going to be 16 minus my y1, which is 0 all over, and then my x2 is going to be 1 minus x1, which is negative 3, and then which is going to give me 16 minus 0 all over 1 plus 3, which is going to give me 4. So the average gradient here is going to be AD is equals to 4. That's the average gradient there. Now 6.5, they're saying let's calculate the length of DE. Now the length of DE, I'm looking for this length that is happening here. So the length has to talk about our y values. Do I have a y of D? Yes, I do have the y of D, which is 16. Do I have a y of E? No, but I can find the y of E because I do have the x of E. And the x of E is the same x as the x of D. Now, how do I find that one? First, let me get a space here. So now I'm doing 6.5. Now getting the y of E on the straight line, now I know my g at x is equals to negative x plus 15. And now I'm looking for the y of E. I know the x value there, it's also 1 and then plus 15. So which is going to give me negative 3 into 1 plus 15. And then it's going to be 12. Now finding the length of D E is going to be top minus bottom. My top is going to be 16 minus bottom, which is 12. And then the length here is going to be 16 minus 12, which is going to be 4 units. That's the length of E. Now, going to 6.6. If the function of h is this one, where f into x minus 1 minus 2 is dead, determine the equation of h in the form of this. Now, what is happening here? First thing, what is my f at x in this form here? I know that the value of a will stick as the value of a here as negative. So I can say this is negative into x. Now, what is my turning point? Because that is very, very important. My turning point is positive 1 here. So if it comes back here, it's going to be negative 1 and then all squared. Then what is my value of y, which is q in this case, 16? So it just comes back as positive 16. Now, I need to do what is happening here in order for me to find the h. So what is happening here, they're telling me that the moment I see x, I put x minus 1, and then here outside into the y, I just put negative 2. So to find the h of x now, it's a negative into, or in the moment I see x, I put x minus 1 as it happening here. And then bring back this negative 1 that was already there, which is minus 1, and then squared, and then plus 16, and then minus this 2, which is going to be minus 2. And then from here, just simplify what is happening here. Is going to be or negative into x minus 2, and then all squared, and then 16 minus 2, which is going to give me a positive 14. And then this is the equation of h in that form, so which is this one. Again, in this one, in this thing here, probably we start by completing a square and everything here, which is going to take a little bit more, but hopefully both of the method are going to give you the same answer. Now 6.7. Now 6.7, they are saying determine the maximum value if p of x is equals to 3 of f at x minus 12. Now I'm going to ask you a very, very important. What was the maximum value of f at x? But the maximum value of f at x here, which is this point, which is our maximum value here, is what? Is 16. So if my maximum value here is 16, in order for me to get this maximum value that is happening here, is going to be 3 into my maximum value here, which was 16, minus this 12 here, which is going to be equals to 3. Now 16 minus 12, it's giving me what? It's giving me 4. And then now 3 into 4 is going to give me what? 81. So the maximum value is going to be equals to 81. Hopefully we are on the same page there. Now 6.8, they're asking us, let's determine the value of x for which f at x plus k is equals to 0, who will have two distinct real root. Now here what is happening, they're asking us if this graph, we can move this graph to the point that it's having two distinct root. So if this graph here from OD going down, going down, going down, how many units can we move this graph going down for it to have also two distinct roots? So the moment we move this graph until this turning point past this x-axis, we are no longer gonna have two distinct roots. Again, the moment this graph also keep on going up, we will have two distinct roots because this will not affect these two x-intercepts that we have here. So how can I write this? So from here I can say x element of real numbers, all the real numbers will have two distinct, but the x can never be what is the x here is going to be 1. So x will never be 1, but all the other x of the real numbers, it's going to be applicable, but x will never be equals to 1 in order for us to have the two distinct real root. Thank you so much guys for watching. Makebalo.